Water Efficiency Credit 3, Water Use Reduction. Once again, more heavily weighted in LEED 2009 version 3, up to 4 points available. The intent is to maximize water efficiency within buildings to reduce the burden on municipal water supply and wastewater systems. So once again, what we're trying to preserve is that potable drinking water. So looking at alternative methods of water reuse is important in this credit. Here we see examples of gray water reuse for both a toilet and a sink. So this credit utilizes the baseline calculated for water efficiency prerequisite 1, which remember does not include irrigation, that is a separate credit, and includes the following fixtures similar to that prerequisite, which includes water closets, urinals, lavatory faucets, showers, janitorial and kitchen sinks, and pre-rinse valves. To earn points for this credit, you need to exceed the Energy Policy Act of 1992's baselines by 30% to get 2 points, 35% to get 3 points, 40% to get 4 points, and if you reduce your water use reduction by 45%, you get an exemplary performance point, which is part of the innovation design section. So there are 6 points available in that section, and 3 of those can be exemplary performance points, which is just exceeding the credit criteria as you see here. There are many examples of low flow fixtures. Kohler has a few examples shown here. An aerated shower head can save 20 to 32% of your water use. And if you don't think that facility staff can maintain a waterless urinal, you could do a 1 pint urinal. And here's an example of a toilet that goes beyond even a high efficiency toilet standard. Pressure light actually reduces the water use by 37% by only using 1 gallon per flush. The key to pressure light is the word pressure, which is once again that vacuum pressure to make sure all waste goes down the toilet even with less water use. Here are more examples of innovative water fixtures, some of which are found more frequently in Europe. And that includes this button to activate 45 seconds of rinsing, so once again you don't get the luxury of just singing in the shower and taking your time, which is a cultural thing to get used to, not having some of those luxuries that we're used to. And one of my favorites is this light signal faucet indicating when you exceed a certain water use. So just telling you red light, using too much water, you're exceeding your quota, get out. But it's more of a polite signal. And another great technology I've run across is this heat sensor. It begins to drip when the desired temp is reached. So if you're turning on your shower in the morning and don't want to get in when it's cold or lukewarm, and you walk away, forget to come back and check in time, instead of just running the hot water, once it gets that temperature, it will start to drip and maintain that temperature. So when you return, your water is at your desired temperature, but you haven't wasted the water in the meantime. Here's an example of innovative rainwater harvesting. This is under deck rainwater storage tank, also called hogs. This is great because it integrates right into your deck construction. But once again, this takes an integrated project delivery to really do well. You have to be coordinating your design, your water budget, how much storage with the contractor to get the correct spacing, amount of tanks you need in order to meet that water budget that you've calculated. The last section of water efficiency category is processed water. This includes makeup water and commercial cooking applications. Next slide. Processed water for cooling towers is especially important to look at because they use a significant quantity of our potable water, our drinking water. The bleed off rates are used to dissolve minerals in dirt, and those can often be set very high. And then there's a necessity for makeup water to replace the water release. So this can be continuously going on, even more than needed. So it's better to use non-potable water for your cooling tower makeup water. So this could be from air conditioning condensate, rainwater harvesting, treated wastewater, or gray water reuse. You need to make sure that this water is treated to a reasonable level though, to make sure you aren't clogging or causing any inefficiencies with your cooling tower that may cause maintenance issues. And once again, facility manager education is very important in this process as well. The LEED credit is Water Efficiency Credit 4, Process Water Use Reduction. This is only available for schools at this time. The requirement is no refrigeration equipment that uses water flowing directly in and out, no garbage disposals, and that 4 of the items listed below do not exceed the stated limits. So for processed water, the equipment types we're looking at are clothes washers, dishwashers, ice machines, food steamers, pre-rinse spray valves, and taking into consideration the maximum water used for each. So the most important thing is to understand the difference between processed water equipment types and the fixtures we're looking at for the water use reduction prerequisite and credit in this section. So synergy with not having a garbage disposal could be composting. You see these in schools around Oregon. Students get really engaged in them. They learn about plant biology and ecosystems. They don't mind getting their hands a little dirty. We also have some offices that are actually starting to do this as well. Once again, there's a cultural awareness of not thinking that having a composting system is inappropriate and actually looking at it as something that can be a benefit and a learning tool even for clients or staff. In this way, you can avoid unprocessed food waste going into the municipal water system from disposals. It's important to look at water efficiency strategies holistically in your site and building design. Take a look at this diagram and think about some of the water efficient credits we've talked about. Pause and then restart after you've looked at the diagram and thought of how it relates to some of those credits we've discussed. All right, so hopefully you notice some of the things we discussed. Let's look at green roofs. Green roofs have a synergy with both sustainable sites and water efficiency. So green roofs help with stormwater management by actually filtering that stormwater, helping with the quality of the water that leaves the site, and actually reducing the quantity through evapotranspiration. That actually cools the roof as well, which helps with reducing heat island effect, which is also sustainable sites credit 7. So we have SS credit 6 and 7, and also sustainable sites credit 5 in actually creating habitat, restoring some vegetation on your site. That water then can also go down to rainwater storage. Now remember, in your water budget calculations, if you have a green roof, depending on the depth of the soil of that green roof can reduce how much rainwater you're collecting. You can also collect rainwater from flow-through planters on your site. That rainwater storage that can then go back up into your building for toilet flushing. Then thinking about where that wastewater goes. So both innovative wastewater technology and water use reduction in terms of potable water use reduction are both seen from reusing rainwater for toilet flushing. Then that wastewater could go to a district black water treatment or on-site living machine to help with innovative wastewater technologies. You also see bioswale here, which is helping with stormwater management and increasing your site rehabilitation. So SS credit 5 and SS credit 6, and also SS credit 7 heat island reduction. So many synergies between sustainable sites and water efficiency credit strategies. Innovation design, we saw on some of these credits. So here's your definition. For exemplary performance is achieving a performance within elite credit that represents either a doubling or the next incremental percentage threshold established by the existing credit. For water efficiency credit 3, that was 45% water use reduction from that Energy Policy Act baseline. 2 to 4 points were available for the credit, and you get an exemplary performance point for hitting that 45%. Innovation design requires more thinking outside the box, so it quantifies an environmental or health benefit with a comprehensive approach or exceeds an existing lead credit criteria with an innovative strategy that has not been addressed in the reference guide. So outside the box or outside of the credit language, where exemplary performance is just exceeding those established baselines within the reference manual. A case study to show innovation in water use is the Pearl River Tower. The cooling tower water passes through embedded tubes in the building. So once again, important to have integrated design where you're planning in this in your actual design and construction of the building. So the water flows in ducts through concrete beams in the structure itself, and then cool air descends down to the spaces below through cold water radiators in the ceilings. Efficient through integrated design. A review of innovation design credits. There are 6 points available. A maximum of 3 points can be from exemplary performance. Once again, just doubling or exceeding those existing thresholds in the credits. This should be submitted during the design phase. You want to include your credit title, description of the credit intent, description of the credit requirements and approaches, and project drawings to support your proposal for innovation design. It's important to know the criteria your reviewers are going to be looking at. It must be comprehensive and it must be applicable to other projects. So it can't be a one-off idea. There's an innovation design credit available for having a lead AP on the team. In lead version 4, there is discussion to have a requirement of the lead AP plus specialty that is coinciding with the lead rating system being met. For example, if you're working on a existing building that's going for lead operations and maintenance, you'd have to have somebody that has the credential for lead AP plus O&M. If it was new construction or major renovation, to get this innovation design credit, you'd have to have a lead AP plus building design and construction, which is what we're talking about today. So in version 4, remember, we're always just upping the ante. And this is one example of where that may happen in version 4. Not finalized yet, but still in discussions. The intent is to streamline the application and certification process and facilitate integrated design by having a lead AP. In order to show you qualify, you need to provide the name of the lead AP or company, brief description of his or her role, and a copy of the lead AP certificate. So hold on to that. Example of another innovation design credit is school as a teaching tool. So we mentioned composting as one program that can get kids engaged. The requirements for earning this is the curriculum should not just describe the sustainable features of the building, but also describe how human and natural ecology interplay with the building. It must be approved by the school administrators. And 10 or more hours must be provided for each student. So it can't just be a simple talk one time. It's really got to be integrated with the curriculum. And the class must be implemented within 10 months of LEED certification. So this is part of the design process as you're certifying the school, is actually creating this curriculum. And this is not addition to the maximum number of innovation design points a school can get. A school can only get 6 points in the ID section as well. Here are the exemplary performance credits for water efficiency section. So for water efficiency credit 2, innovative wastewater technologies, the requirement to get exemplary performance is no potable water to remove sewage or prove it is treated on site, the living machine or anaerobic digester of some sort, or other technology. Water efficiency credit 3, water use reduction, is 45% water use reduction from fixtures, fittings, and appliances. Water efficiency credit 4, enhanced refrigerant management for schools only, is show a 40% water savings. This is in your processed water. An example case study of comprehensive site planning and building planning to reduce water usage is Dockside Green. This is in Victoria, BC. It has a mix of residential, office, and commercial buildings, and even light industrial. It's 1.3 million square feet, and its wastewater treatment and reuse is very innovative and very effective. This is actually a built project functioning today. They're actually going to be expanding it to supply water to the city as well. Dockside Green uses an innovative technology called ZeeWeed for their wastewater. It's a GE water and process technology called ZMOD. It's a packaged wastewater treatment plant. So it's a membrane bioreactor. It's very compact. It's said to be odor-free, which is pretty impressive on this large scale. And it does this through combining activated sludge processes that are pretty common with also a barrier for ultrafiltration. So that's that membrane fiber you see on the right. It's a very, very, very microscopic pore membrane. And clean water comes out the end. Here's an example how the ZeeWeed membrane works. So raw water first flows through a concrete bioreactor tank where bacteria consumes or digests the biodegradable waste before it enters the membrane chamber where the ZeeWeed membrane is immersed. So you can see it can go out to water features, toilets, other reuse. This is a diagram to show the holistic design that went into this site planning for this innovative wastewater technology, and then how it has synergies with other LEED credit categories. For example, you have an irrigated green roof that's helping with stormwater management, heat island reduction, and restoring habitat for sustainable sites section. Reusing the water for toilet flushing for innovative wastewater technologies, reducing potable water use for that, which also has synergy with water use reduction credit. You also see bioswale filters going in the system, which helps with stormwater management and treating the water on site, once again helping with innovative wastewater technology credit. The clincher is the city will not bill residents for the sewage component charge of their water bill or the use of treated water. This just goes to show how important it is to be an advocate in your local jurisdiction. I worked on one of the first living buildings that was designed to have net zero water usage here in Portland. It's called the June Key Delta House, and at the time, rainwater could not be reused for toilet flushing. But through that process and a city grant, now rainwater can be reused for toilet flushing. At a certain time, they did require a sign that said, "Do not drink the water." Maybe dogs can read, I don't know. But that since has changed as well. So being an advocate is important to help these sustainable strategies go further and further. That's the end of this section for water efficiency.